Hey guys, welcome to Fed. My name is Gregor Weideman, and I'll be talking about the research design process that we kind of went through. So the first step we kind of had to do was ask essentially what are we trying to do? What's the problem that we're trying to solve? And how we went about that was looking at the rubric, looking at the constraints, all the different stuff that we had to take into consideration to kind of create a foundation of how we're going to approach the problem. Then next we went into kind of research. We used books and online articles, as well as fellow team members that work at the full star reactor and started up during the day. Using those resources, we were able to kind of figure out what direction we need to go in and the parts we'll need in our design. So for Imagine, we used the research process to imagine all the different type of designs we can do, the type of plastic we want to use, the pipe we want to use, how we're actually going to record the data, and everything like that. Then we planned. We figured out what our timeline is going to be for building, what our timeline is going to be for all these different deadlines that we've had with the class. And now we're here at Fed and just like having the poster ready and just getting here on time and present it. Then we went into the create stage. When we actually started creating, we got the supplies from Home Depot, got the supplies from home, from engineering workshops, and then we actually started building and testing. One of the major tests that we did was making sure that water wouldn't seep into the pipe and destroy any of our equipment, as well as light sensitivity issues. We made sure that there was nothing like that in regards to the angle that we'd be taking the pipe into the nuclear pool, and then improve. So after all those tests, we figured out that everything was pretty locked and secure, so there was nothing else we had to really add. So yeah, that's what we had.
I'm Audrey Schmall, and the problem we were trying to solve is the creation of a probe that can detect power level based off of sensor readings. Some constraints we had were a $40 budget, and we also had to make sure that the fluid we used was not water soluble so that it didn't fall apart when we put it in the reactor. Additionally, we had to make sure it was free of debris before we entered it into the reactor, just for better readings and to make sure we are adding details.
Hi, I'm Nate Searles. I'm lead designer for our nuclear probe. So I wanted to take you guys through the design process that I went through, some challenges, and what I would have done differently. So our nuclear probe is made out of PLA. We have a couple of photodiodes on the end to measure the actual light level, and we have an Arduino that reports back to a computer and lets us know a power level for the reactor. During design, I used SolidWorks and a Bamboo Labs X1 Carbon 3D printer to print the actual design. The material is PLA, and it will just slide down into the pipe and rest at the bottom. Some things that I would do differently next time. First of all, to secure the actual wire for the Arduino. During testing, we had an unfortunate failure where our wire did come unplugged about halfway through testing. We were not able to complete the project in time. However, we did get a couple of data points, and those will be talked about later.
Alright, I'm Josiah Wilder, and some advice for upcoming freshmen next year is I would definitely say start as early as you can, because at the end of the year, you're going to be very busy with like finals and studying for all your exams, and like doing all that work for Fed is definitely going to it's going to pile up. So I would definitely recommend meeting with your group, getting as much done early as you can, in order to kind of maximize the quality of your projects, but not rush it essentially. So yeah.